Hello students, today we are going to talk about a new topic on adding or multiplying a number to a set of data. And let's say, for example, we have 7 students and each of them has some cash in their pockets. And we have to find the mean, median, and mode of the cash of these students. And therefore, for part A, mean, again we simply add up all those numbers, 45 plus 55 plus 70, 60, and so on. Sum up all these and then divided by 7. And by using our calculator, the answer is $57.1. And for the median, we have to arrange the number in ascending order first. For example, we have 45 and then 50. Next will be 55 and we have 360 here. And the largest one is 70. Since we have a total of 7 numbers, 1, 2, 3, 4, 5, 6, 7, therefore the middle one, this one, it will be our median, that is $60. $60. And of course, the mole, the amount or the number with the highest frequency is $60 too, because we have 360 here. And for part B, if each of them use $12 to buy a cup of ice cream, that is, each student, the amount of cash of each student will be decreased by $12. So 45 becomes 34, 38, 43, 48, 48, 48, and then 58. And now the new mean, it can be found in 2 ways. And the first one will be, we just simply add up all these numbers and then divided by 7. And if you use a calculator, then this will be $45.1. But there is a second way, and since if you compare the new mean and the original mean, it differs or decreases by $12, which is exactly the amount of money which each student used to buy a cup of ice cream. So actually we can also check the median. The new median, of course, this is the middle one, $48. And again, if we compare the old median and the new median, it is also decreased by $12. And so did the mole. We have $48 too, because we have free $48 here. So decrease a set of data by the same amount will cause the mean, median, and mode to be decreased by the same amount too. And therefore our conclusion can be like this. Actually, we don't need to know the exact amounts of money inside the pockets of each student. Actually, we don't need this in order to know the change of the mean, median, and the mode. All we have to know is the amount by which the pocket money is decreased or increased. Which is this $12. All we have to know is just this $12. Okay, now we come to example 15. And actually, in my opinion, this problem is not that good because the wording is rather complicated. And in the year before last year, the mean, median, and mode of the monthly salaries of the employees in the company were like this. And each employee received only a $500 of increase in salary last year. And this year, due to the increase in profit, then each person is offered a further 2% increase of salary. Find the mean, median, and mode of the salary this year. So to make the problem a little bit clear, we simply draw a timeline to show the whole situation. So this is this year, and this is last year. And this is the year before last year. And so, from the year before last year to last year, each employee received a $500 increase in monthly salary. And from last year to this year, each employee received a further 2% increase in salary. So in order to find the answer for this to this problem, we can make use of the old mean, original mean. New mean, it should be 12000 plus 500, and then we increase this by 2%. So this is the new mean. And by using our calculator, this is 12750. And we can repeat this for the new median and new mode. The old median 14500. We increase this by 500 and then multiply this by 1 plus 2%. And the new mode, we did the same. Increase this by 500 and then multiply this by 1 plus 2%. So we have $15300. And for the new mode, we have $9996. Okay, example 16. We have to find the mean, median, and mode of this set of data. And note that this set of data is already arranged in ascending order. To find the mean, we simply add it up. And we divide this by 9, since we have 9 numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9. And we have 25 as the mean. And for the median, we have to find the number at the middle. So this will be the 5th one. Therefore, the median is 25. Mode, the number with the highest frequency, which is 27. And now we come to part B. If the datum is a singular form of the word data, remove 27. And will the new mean be greater or smaller or maybe equal to the original mean? That is, we now cross out 127. And actually, the new mean can be recalculated by adding all the remaining x numbers and then divided by x. But the problem requires us just to answer whether the new mean will be greater or smaller. So actually, we can do a prediction first. We remove 127 from the set of data. And how can we make the prediction? We should base on what criteria to make our prediction. And it is rather obvious that we have to compare the data to be removed and the original mean of the set of data. Since this number is greater than the original mean, that is, a number larger than the mean is removed. So the overall effect on the set of data is that the new mean will be decreased. Okay, the new mean is decreased. And we can prove this also. And this is just a proof or the evidence. We can actually find a new mean. and then divide this by 8. And then using our calculator, we get the answer 24.75. So this is our evidence. But actually, in our prediction, we base on the comparison of the data to remove and the original mean. So therefore, the new mean is decreased because the removed data is greater than the original mean. This is our rationale, our reason. And now we come to part C. If the datum 23 is deleted, will the mode change? So we can see that even if we remove the data 23, the mode is still 27 because we still have free 27 in the set of data. Therefore, the mode is not changed. And for part D, if a data 0 is added, will the median change? So we add 0 to the set of data. And we assume, that's right, this is 25. We assume part A, part B, and part C, part D, they are all independent cases, independent paths. And now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, a total of 10 numbers. So the number at the middle will be between the 5th and the 6th number, which is 25. And therefore, it happens in this case, the median is not changed because the original median is also 25. So the median is not changed. And look that we have to actually find out this fact because sometimes the median may be changed if we add or remove a data, and it will vary from case to case. This is very important.